So now let's use our similarity postulates in some example problems here. We've got 5 of them total. So I've got 2 triangles right here, boom, boom. Now looking at these, they do give you all 3 sides of each triangle. So I would naturally think that I'm going to use the side similarity postulate to prove them similar. But let's see if that works. We have to compare the corresponding sides and see if they're proportional. So if you look at these 2 right here, they're basically mirrored images. Like if you had a mirror right here, they're kind of flipped. So if you compare side 15 to a side over here, it'd have to be to side 5. So if you compare those, you could say 15 to 5, which is just 3 to 1. Okay, but let's see if we get the same ratio when we compare the other sides. For instance, if I compare 10 to 5 down here, 10 to 5, well, that does not reduce to the same thing. That is 2 to 1. So these are not similar. So over here we would just say not similar. And then we would not need to write a similarity statement. So let's look at the bottom one down here. Let's look at what they give us first of all. We've got a side, and an angle. Same over here, a side, and an angle. So, I might think side, angle, side, right? Wrong. Careful with that one. Side, angle, side, if you notice, if I write that out, for instance. Side, angle, side. Notice the A is in between the 2 S's. So it's talking about a side and then the included angle on the other side. So it would have had to mark those 2 angles congruent in order to use side, angle, side. So, and then there's nothing else that works here, so this would just be not enough information. We can write that. Not enough info. Okay, so we haven't proven anything similar yet. Let's look at the other examples. So the only thing they tell me about these 2 sets of triangles, notice I say 2 triangles because we have this one right here, and then we have a big one. Boom, boom, boom. Okay, so 2 triangles. And the only thing they show us is that we've got parallel lines here, here. But that actually gives you quite a bit of information. If I have parallel lines, then you could say this is a transversal right here going through them. So these 2, this angle and this angle are corresponding angles. So those are congruent. And then if you also look, we've got, let me change my color here. Okay, we've got another transversal over here. So we could also mark this one and this one as corresponding angles. So those are also congruent. And then since we've got an angle congruent to another angle congruent to another angle, then we can say these 2 triangles are similar by the angle-angle similarity postulate. So let's just say, we'll say they are congruent by angle-angle similarity. I'm going to draw my similar symbol. And then they do want us to write a congruent statement. So just be careful that you correctly write the order of all the vertices. So for instance, let's look at this small triangle. I could call it triangle JIH, sure. All right, so let's write that. Triangle J, oh, this is hard to write, JIH. And that would be similar to triangle, let's look, JIH, so that would be similar to triangle JFG. Let's look at these triangles down here and see if we can prove that they are similar. If we look at our little triangle, I know a side and a side. Okay, if I look at the big triangle, I know a side and another side. Well, we can't do side because we'd have to know the measurement of those. But look at what else you are actually given. We have vertical angles here. Got an angle right here. Oops. And this angle here. So those are congruent because they're vertical angles. So now I've got a side, an angle, and a side, an angle, and a side. So I might think side, angle, side, but in order to do that, you have to check and see if the sides are proportional. Now I look at 3. I can compare that to this side over here, 9. So let's compare 3 to 9 and reduce it, which would be 1/3. Let's see if that's proportional to, change my color. Let's compare side 5 to side 15. And you can already see what's going to happen here. that also reduces to 1/3. So we have the same similarity ratio here. So yeah, our sides are proportional and we have congruent angles included. So these are congruent by side angle side similarity postulate. I'll just go like that. And then you've got to write your congruent statement. So we would say triangle, let's look down here first. If I say triangle, let's go from D to F to E. Triangle D, F, E. That would have to be similar. If I say it the correct order over here, I'd say from side H to F to G. Oops. Triangle HFG. Let's take a look at our very last one here. We got our triangles. We know one angle is marked congruent to another angle. Well, that's all they tell us, but there's one other thing we can infer. We've got a right angle here. So this one, these are vertical angles. This also has to be a right angle. So now, if I know two angles are congruent to two angles over here, then that proves that the two triangles are similar by the angle-angle similarity theorem. So, yep, they are congruent by angle-angle similarity. And then you just have to write your congruent statement, and this would be triangle, let's see, how do you want to do this one? Let's go from A to C to B. If I do that, triangle ACB would be similar to triangle. If I started at A over here, I have to start at E over here. ECD. Similar to triangle ECD. And yay, all done. That was easy, right?